Hi folks, I'm Shubham. I'm one of the maintainers of Keploy, and in this video we'll be doing a deep dive on Keploy's Go SDK. I'll take an example and show you what different high-level methods are involved during both capturing traffic and generating test cases as well as running the test cases and getting reports. This is this video is useful for somebody who is trying to contribute to the Go SDK to help understand the architecture and how it's written, as well as anybody interested in building or contributing to um, any other language SDK, for example TypeScript, JavaScript, Python, Java, or any other. Since this is the first SDK we made, so um, this can quickly help you understand the basic principles behind and thought process behind building the SDK. So to get started, this is the repository. It's open source. Everything, Keploy itself, the core, the SDKs, everything is open source. And the way it's structured is you have the Keploy folder which has the core methods. So for example, all of this would be common. For example, context, the core Keploy methods. We have different utility methods and all of that. So this is the core library. And then we have integrations where we have integrations with different libraries. So for example, and it's all appended with K to avoid package conflicts during imports. So KG is basically the Chi router. This DynamoDB, Echo V for Gen V1. So Gen V1 and Echo V for routers. Again, KGRPC is for the gRPC client. The KHTTP client is the HTTP client. So we have Mongo, the Mux router, the SQL. This is used for all. This is a common interface in Go for SQL databases, and WebGo router. So this is how it's structured, and all of these integrations. You can add more routers or dependency calls here, and they all essentially use the Keploy methods. In fact, if somebody wants to add a new one, you can do so. Similar to how the existing ones are written, or you can use Keploy methods directly into your application. You can also go through how basically the SDK works, like from a user point of view. And if you're watching this video, I'm assuming that you already kind of understand what Keploy does, so I will skip that part. So to take an example, I'll be taking the Gen Mongo example, which is also available. So it's inside the samples repository. So I'll be taking this for this particular demo. I currently have Keploy running on localhost 8081. I have a few test cases generated. Since I have this application name, maybe I'll just change the application name for the demo. So if I go here, I can rename this to 2. Right? So in this particular example, we are using the Gen router. So here's the integration point, and we are using DynamoDB. So here is that integration point, right? And now to quickly run it, when I do run it, okay, so the application is running. In fact, let me just start in debug mode so that I can show you what all statements are getting executed. I'll use hopscotch to quickly. Yeah, so we can do a post request, and as soon as I do that, so now this, and like this particular place, this is the kgen file, right? So it's inside integrations kgen v1. So this is the middleware, and up here is the initialization code, and this is the actual middleware. As you can see, we have the Keploy instance which is being injected while initializing the middleware. And the first thing that the middleware checks is if there is this Keploy test ID header. Since this is only present if we are in test mode. So since we are not in test mode, as soon as I go further, you can see it is nil, so it will not, it'll go outside this flow. And in this mode, by default, it's in test mode. So the SDK's behavior right now is to be in capture mode by default. So it's setting the context. So what happens is the context is set in the middleware, and that context is propagated throughout the life cycle of a request. So in this case, as we can see, we are setting the Keploy context. In fact, I can go inside this. You can see that I'm creating context and setting the request context, right? And we have this Keploy context variable, which we're setting. And in fact, if I go further, you can see that inside the context, I'm currently setting mode as capture. So what happens during capture mode is that so I mean, here essentially I have mode, I have test ID. So in this case, I mean, we're just capturing traffic, so there's no test ID generated, so that's going to be nil. And then the dependency. So as this context object propagates through the request context, any dependency, for example MongoDB call happening, it would be serialized and injected into the context, right? So if I go back here, right now it's just doing the usual stuff in which it's trying to wrap the trying to read the request so that we can capture the request, and also wrapping the response body so that we can read it later on. So that's what's happening here. And yeah, so capture gen is wrapping the response with a body dumper so that we'll be able to dump the body. And c.next essentially kicks off the next part, in which, so until here the actual handlers have not been called. That's how middlewares are written. So if I keep going further until here, so this a way to ensure that we're able to capture the response calls. Okay, so in c.next, what happens is it actually goes inside the rest of the application flow, so the other middlewares and the handler itself. So it looks like it has stopped. Have I got a response back? No, I have not got a response back. So it has stopped for some reason. It's not the debugger. Let's do the request once again. Okay, so we're here. Okay, so after that c.next, basically we would come here. This is the put URL for inserting, and here as we can see there is this upsert method. If we go inside the upsert method, okay, I'll just go so this is the upsert method, and as you can see here I'm doing a database call, and since the client is already I mean we've already wrapped using kmongo, which is a wrapper around Mongo. So when I go inside this, what's going to happen is it's going to get the context, right? So the context which was set by gen, right, that is being passed here. So from here it's able to first it will check what the mode is, so you can disable Keploy, and if it is disabled it will just return right here with the usual response of what Mongo would return, so that there is no disturbance within the application. So that's not the case. We know that the Keploy mode is, like as we can see, it is capture, which we had set in the middleware, and it's going to do the usual stuff. Here the idea is that it's going to get the output of the actual update one method. So it's going to do that, and once it does that, so now it has the outputs, and now it's time to serialize those outputs. So that's what, and here we're also capturing some metadata which will help user understand more, especially while they're going through the test cases. So here we're capturing different metadata. So once those metadata capturing is done, process depth is an interesting method because it helps in serializing. So it helps in both serializing and deserializing. So as you can see, there are two modes. In test mode, it would, you know, deserialize. So it would have the binary uh, which was captured earlier, which was captured, and it will convert that to the database objects or any dependency objects. While during capture, it will uh, convert those dependency objects or Go objects into binary. So it's here we use GOB to encode that. So that's the case here. So as we can see, we're making that, and finally, when all of that is done, it would return the yeah. So it's appending into the context itself. So within the context, we have this dependency array, and in that, we're appending all that information. So far, what has happened is this process dep, it has saved the Mongo response, that actual MongoDB response which we got from the database. It has saved that to the context first by serializing it using GOB, and then saving that serialized binary into the context using the there's this dependency here within the context, so it is appended there. Cool. So that's it. That's what this method does. So essentially, we capture the response by serializing into a binary or a byte array, and it's now injected into our context. Perfect. So that part is done. Now, what we would do is, let me put a debug statement somewhere here. Yeah, we do that. So yeah, after that, the whole database call happens. It captures the response. Now we're here. So now if I go inside the context, wait a minute. So K is our context, right? Yeah. So we have this dependency depths, and okay, no. So K is the object. Sorry. We would go inside. How are we accessing the context? Keploy context. Okay. Capture response. Params. Okay, so that's happening inside this method. Okay, so step into, and as you can see, D we got from context, and within D, mode is captured, test additional, because it's in capture mode. Then we have this array which has the MongoDB data. So only one call happened, and this first one is the it's basically the binary of what that object was, and second is basically nil, because second generally based on the since I've seen the implementation, it's basically for the error, so that's basically a nil object. Yeah, so that's it. And then we have a bunch of metadata. Okay, it's MongoDB, it's a NoSQL database, what the operation was, what the filter was, what the update operation was, all of that. So that's in the metadata. Now all of this would be now sent to the server. So let me show you how that works. So k.capture is part of the core Keploy. So it's a core Keploy method. Like I said, so if I go back, like it's part of the core Keploy framework, right? So it's within this Keploy.go. So yeah, we could, it's basically trying to capture all of that. So it's trying to capture the time when this happened, the app ID, the URI, the HTTP request, the response, and the dependency calls. Next, this is the capture method, and as you can see, all the capture operations, we want that to be asynchronous. So it's running in a separate thread to avoid impacting response time of the application. So within put, as you can see, now we are going to package all of that information and send to the Keploy server. And here the interesting bit is that after all of that is done, we marshals and an HTTP request, we get an object in which we are expecting an ID, and what this ID represents is, this is the test case ID. So when I'm sending a traffic capture to the Keploy server, there's a deduplication algorithm which can be disabled, and if the request passes through that, then it would be considered as, it would be then considered as a test case, and when it becomes a test case, there's a test case ID, and that's returned. So here, if the test case ID is nil, that means it was discarded, so the flow stops here. Else, if we get an ID back, that means that request, this whole request, response, and dependency, this whole thing became a test case. So we'll have the test case ID, and now there is a second request which we do, which is denoise. So denoise helps us identify random parameters like random numbers or timestamps, which can be noisy in a test suite. So to do that, we'll go there. So how denoise is working is, definitely we have added a sleep here, so that just to have time difference, so that those time-based variables would change enough that we'll be able to capture the noise. And here we have the simulate method. Now this is also interesting. So what simulate is going to do is, it's going to now redo the same request again on the server. So we did a put request in which we were putting a URL and we're getting back a shortened URL. We're going to redo that, since we just captured it. So to do that, this is what's going to happen. First, it's going to store the dependencies into the Keploy object. This is so that we can mock the Keploy object, right? So this is stored, and there's a defer delete that this is a map. So after this method is done, simulation is done, delete it just to save memory. And as you can see, the request that we're doing is same as what we captured. So so this is the host, right? But we're capturing the exact method that we're getting. We're capturing the host of the application where it's running, right? And next, we would be now building the using the same headers, and here we're adding the test ID header. So this is important. This test ID header will now change the behavior of a middleware, right? So all of that's happening. We're trying to set the same protocol, major, minor versions, right? So all of that's happening here. Cool. Now here is when that request would be actually executed, right? So in fact, let me add a breakpoint here as well, and let me see if I have a breakpoint within here. Cool. So now, as you can see, I did the request. Now it's again in the middleware, and this time the ID will not be null, right? So recap. We first time when the request comes, it's in capture mode. Once it's captured and it becomes a test case, we are now going to check if there is a noisy field. To do that, we replicate the request once again, right? And what's special this time is, since it's in simulation mode, we will not be hitting the databases. We'll be mocking them. So I'll show you how that works. So in this case, as you can see, test case exists. So now it's going to be part of this flow. And here we're setting the Keploy SDK mode, and this time it's in test mode. We're setting the test ID, and we're getting back the dependency that we just set. So we set the dependencies here, right, which we just captured, which is MongoDB call, and we're setting it back here, right? So we're getting it from here and we're setting it back, and again doing the same capture response, in which we want to see what the response, like we want to capture the response back, right? So again, similar flow. So again, it would go to the put URL method, which would go inside upsert, which will again do the database call, and within the database call, now there's going to be a difference, because we'll not be hitting the actual database, right? Instead, now since it's in test mode, right, we would be context deadline exceeded. Okay, so this happened because we are slowly going through the request. Cool. So what I'll quickly do is redo the request once again, right, and come back here and continue. So to do that, we'll do this. and okay. Okay, so in this case, what probably happened is it did not pass deduplication, so I got nil ID, right? And so it did not go through denoise. So to show you how denoise works, I'll need to change the application ID once. So let me do that. Cool, so yeah, let me make it 3, right? So it's a different application according to Keploy. Perfect. We do this again. Process dep, capture test case, goes here, goes to denoise. So we're getting a simulate, going to redo the request, goes into upsert, goes into the database. Now we're coming here, and this is where we left off. This time it's in test mode, so it's not going to do the actual database call. Instead, when it's this metadata, it's going to go inside process dep, right? And within process dep, it's going to get state, and now we can see it's in test mode. So it's going to go through the test mode part, and there it's going to decode and regenerate the responses that we got back. So in the binary, I mean, we had the captured binary earlier. Now we're getting the actual objects back from the binary, right? And once that is done, the whole application runs as usual. We have, the simulation thing is done. Now we're getting the response back, and once we have the response, now this would be returned, right? So simulation is done. Now this would be again sent back to the Keploy server, the second response, to check if there is any noisy field. So then it would compare key by key, and it will try to find if there is any noisy parameter, right? So this is all that code sending this to the Keploy server, and yeah, that's basically it. So this is the flow. So second request was done, it was mocked this time, and it was sent to the Keploy server for denoising. And in fact, if I go to the UI, you can see how the denoising. So I have this 3, and I can see in the raw events that the denoising added body.ts as a noisy parameter, because timestamp will always be different. So second time when we did it, it probably got a different timestamp, but the URL was same. So it marked this as a noisy parameter. By noisy parameter, what we mean is it would be ignored during future comparisons, right? So body.ts will not be used. It will be automatically ignored, even though it will be different, right? Now, let's go through a test flow, right? Now this is how we capture. There's like one end of a phase here. Capture has 2 parts, the initial capture and then denoising, right? So we covered 2 parts of capture, and now we're going to cover how we're going to test it. So to test it, we have integration with go test, right? And what it does is it just sets it to test mode, runs the actual application, and just waits once the test cases are done. That's all, right? And it uses the test object just to print any errors. So very lightweight integration, doesn't do much. And so let me show you how that works. So if I start this, in fact, let me start this in debug mode. Right, so there's a delay, like as you can see, test starting in 5 seconds, pre-configured delay. Yeah, so it is. So we're back into the simulate method, right? In fact, before that, let me show you what actually happens. So when you do this, it's actually the test method. So let's go through here, right? Cool. So let's go once again. Now what's going to happen is when you start this in test mode, right? In fact, you can see here, this is the Keploy initializer. So if it's in test mode, it will run a separate go routine, right? Its go routine is similar to how a thread works. So it's asynchronous, right? And k.test. This only runs if this is in test mode. Rest of the application is working as it is, right? And here what we're going to do is there's this time.sleep, which is that delay we were just talking about, just to allow application to set up. So the default value is 5 seconds, and then k.fetch. Inside k.fetch, we are fetching all the test cases from the backend Keploy server. In this case, just one test case that we just captured, right? So once we do that, as you can see TCS, it's an array and this is only one item, and this is the whole test case object. So it has the request, response, dependencies, all of that. So the same dependencies that we captured, that same Mongo call, right? And the same request response. And also what the noisy parameter is, body.ts, right? We have that. And yeah, so let's move forward. Once this is done, then it would run the test cases one by one, right? Here we have this wait group. So what this is doing is, in Go, this is a way to control how many concurrent threads, concurrent test cases are running. So here we have configured it, we've currently hard coded it to 10. So at a time we would have 10 concurrent test cases being run, right? And yeah, and each of those, like I said, they're asynchronous, so they're running their own thread, and based on that, it would then return if it's a pass or fail. And what is also interesting is this k.check, right? Because in k.check, what's happening is it's calling the same simulate method we saw, the same flow, and after simulate is uploading the response to the Keploy server to check if it's the same, depending on the noise and all of those parameters, is the same as before or not, right? So at the end, when the Keploy server says pass, it's written true, else it written false. And based on that, the overall test case would fail or pass. So if you understand how the simulate method works, this is very similar. So in case of check, we call simulate and we upload the response and we check if it's matching or not. In case of denoise, again we call simulate and we upload the response, but it's to check if there are noisy parameters, right? Similar operation, but for different purpose. So, yep, that's a brief about how the Keploy SDK works. So this is the test mode. Test mode is basically the simulate mode, but instead of getting the getting noisy parameters, we're uploading response to get the result of comparison, right? And finally, all of that, this is all that the SDK does. All the comparison happens in the backend, and the diff you see on the UI, that all happens on the backend. So if I let it continue, you can finally see that test case passed, blah blah blah, test case coverage, right? Sorry, I didn't run it in coverage mode. If I do run it in coverage mode, it would give me the test case coverage as well, right? And in fact, let's just quickly see that. The benefit here is that since we're using Go test natively, I can reuse all the tooling. For example, the Go test pipeline that exists for almost every platform. The native integration with IDEs like JetBrains have with Go test automatically, because we integrate with Go test. So since it's a very simple program, that one API call is giving 64% coverage, right? And yeah, another cool thing is it allows people to use Kepler along with existing test cases. So if you want to write unit test cases for some specific methods, it's going to work alongside that and give the combined coverage. And yeah, and all of the UI stuff. So for example, if I go here, I go to test run, right? And this is that test we just ran. You can see that this is different, and that's okay, but this part is same, so it's not failing, right? And all of this comparison happens in the backend. SDK just uploads the response that is captured during test case mode, and during capture mode it uploads everything, the request, response, dependencies, and second response for denoise. So that's a high level summary of how Keploy SDK works. This is just the first video around this. We are constantly developing the SDK. We're adding new features, improving the overall experience, and I'm sure there's going to be a lot of revisions, and we'll be building documentation for this as well, which would also be constantly being updated. So feel free to once you watch this video, if you've made it out till the end, please ping me on Slack. in our group. My handle, I mean, you should be able to find me. I'm Shubham Jain. And yeah, I mean, if you would like to contribute, um, we'd love to help you get started, and can also give you a diff around what changed since we shot this video, right? So thank you. I hope this gives you a summary. By the way, today is 17th March, so this is when we shot this video.